Hello, this is Miss Dagenford, and I wanted to help those who missed Friday's class. I wanted to get you caught up. So, where we were on class Thursday, we were talking about the physiology of the eye. We went over, pardon me, we were talking about this worksheet, and we took some notes. The one that we were about to start, but I wanted to do it in maybe a more expanded version. So you're going to see I'm essentially covering 1 through 4 and then a little bit of 5. And so that's what you're going to see during this video. So our goal in this video is really hammer home some of the details of the eye physiology. So let's go ahead and get started. So you should know by the end of this video, you should be really comfortable about how the cells work and how the eye perceives light and dark throughout the day. So pause the video whenever you want to as you take notes. So we're going to start with how the cones work. Now the excitation of the cones. Let's first draw the back of the retina. Now the back of the retina, you're going to have a whole bunch of these little cells, the rods and the cones, and of course the other neurons, and light is coming in this way. Now, let's go ahead and magnify a little section of this. So you'd have these cells, some of which are rods, and some of which are the cones, and they are kind of shaped differently. And here's another cone. And let's do one more cone. And my picture is not very good there, but we've got these cones. Let's make them much more triangular looking there. There we go. And so we got these cones that are perceiving color. Now they're going to operate in a similar fashion to rods. They have a pigment inside of them. So this little pigment, let me just enlarge one of them. This little pigment, just like rhodopsin, this little pigment inside is going to change its shape. But how it changes shape, so it has a shape when it's not activated, and then it has a shape as it's activated. So the light hitting it is going to activate the cones. Now, why the cones let us see color is that each cone, each type of cone, will perceive different wavelengths of light. So, let's go ahead and pick. Let me go ahead and get the line smaller here. So let's say we have red wavelengths coming down. Now, the red wavelengths coming down might signal this cone, and if it signals that cone, it's going to send a signal to the brain, and the brain is going to perceive that as red. Now, here's where it gets interesting. It might signal another cone, but let's say that cone only responds a little bit. And so this one maybe perceives more yellow. Well, as that sends off a signal, that signal is not going to be as strong. It's not going to be as frequent. So the brain's going to interpret that as just a little bit of yellow. And so maybe you are in fact seeing orange. So what your brain does is it combines what the cones are telling it. Let me show you a graph here, and your book has something similar to this. So let's say one cone is really strong with the red. It's sending a signal off, and the brain perceives it as red. But what if there is another cone, and I don't think the yellow is, well, we'll try. Let's say another cone is getting a signal kind of right in here, and it's sending off the signal to the brain. Well, the brain is going to get both signals, and it's going to add them, sum them together, and you're going to perceive that collectively as orange. So if this one's sending a signal off, you're going to perceive that as orange. So what happens if you then get a blue wavelength? Well, let's go ahead and draw it out. So let's say it's not, the only one that's activated is the blue cone. So the blue wavelength comes in, that blue cone is now activated, and then it's going to send a signal off to the brain. And so ultimately what happens is it's the combination of what cone is stimulated and to what degree it's stimulated that then the signal is sent to the brain, and then the brain integrates this information to give us all of the hues that we might see. Now, the only thing we need to then talk about is what happens during the day, when we go from darkness to day or day to night. So we're going to first talk about light adaptation. And light adaptation would be when we go from dark to light. So I'm going to scoot my notes up a little bit here. So let me first get a darker, there we go. Let's first talk about the dark. So you wake up it's 5 a.m. You know you have to get to school early. So it's 5 a.m. And so let's go from there. At 5 a.m., it's dark out still. The rods are set for dark. And we'll just say it's dim light, right? So that means the rods are on. Now that's going to be in the dark. So you go to the bathroom, you turn the lights on. So this is now going to be light. So you switch that light on, and immediately all rods detect that huge influx of light. Now that's too much for them. They work best in dim light. So all rods are what we are called bleached. They actually do lose their color. Now what that means is it went from that cis form to that trans form where it straightens out. Now, on a more informal way, that means that the rods basically turn off. They don't do well in bright light. So what happens to the cones? Well, the rods turn off, but now the cones turn on. They now become activated because cones work best in bright light. So the cones become switched on. And that takes only about 60 seconds. And this is that moment in time when you flip that switch in the bathroom, sorry. You flip that switch in the bathroom and you cringe as that bright light hits you. Now, the technical way of describing it, we would say that the retinal sensitivity is lost. Now, this seems counterintuitive, but let's make sure we're aware of what that means. Think about what happened. The rods, which worked best in dim light, the rods are off. That means if you went back to being in the dark, you're not going to be sensitive anymore to the dark. The rods have to turn back on. Cones work great in bright light, but that means they're not very sensitive to the dim light. So the way we describe it is the retinal sensitivity is lost. However, the visual acuity, sorry about that, the visual acuity is gained. We have increased our acuity, and that means the cones are on, and they give the best acuity. They have the sharpest vision. Because remember, each one of these cones can send a signal to the brain. They're going to go up to the nerves, and then that signal is going to go to the brain. So your brain has a really good message from all of the cones, and it gives really great detail. So that's the light adaptation. So that happens pretty fast. So what happens in the dark? Well, the dark adaptation, that means we're going to go from the light, and think about it, what that means. Cones are on. And then it's bedtime. We turn the lights off. We are going to go to sleep. Lovely, lovely sleep. And so we turn the lights on. Now that means we've got to get those cones back to active. So the rods. So the cones actually become inactive. The cones go off because they don't work well in the dark. Now, let's sneak back to the light just for a second. During the daytime, the rods are actually stored away, that rhodopsin. It kind of gets decoupled and packaged during the day. So they are stored, and so we don't want them on because that can kind of destroy them. So we want them off for the daytime. So when the cones go off, the rods need to then be activated. So what we do in the retina, all of the cells, all of the rods now turn their rhodopsin back on. They activate the rhodopsin. Now that's going to take a while. So the rhodopsin accumulates in the rods. Because this takes a while, this is a slower process, and it can take upwards of 20 minutes for you to start seeing pretty well. Now, you might start getting some of the vision less than that before that 20-minute mark, but you really start seeing things very decently at 20 to 30 minutes. But it can really take upwards of an hour or so. And think about this, if you were to wake up in the middle of the night, you can navigate your room okay once you're kind of awake. You don't have to turn things on. It may not be precise, but you've got it. So now the visual pathway, we need to go back to our sheep brain to kind of remember. So here's the underside of our brain, and here would be our two eyes. What's going to happen is that optic nerve is going to come down the underside of our brain, and it's going to cross. That's that optic chiasm. Chiasma, sorry. And then half of the nerves go to the right side, half the nerves go to the left side. And so you're getting an integration of the two eyes. And that's what our brain can do at that point. So that's going to be the optic nerve. And when we do the eye dissection, you're going to see how big that is. That's one of the biggest nerves we have. Well, I hope that helps finish off the eye. And you can record any questions that you have. Thank you.